Coming back. Okay, we have done now the gas stoichiometry problems. Okay, calculations. Now we've done to the gas. Now we go to mixture, right? Classification of the matter and the changes of matter. Okay. I will never introduce myself anymore because you know me already, right? Okay. Classification of matter. Okay. Like that. And then the changes of matter. Okay. Changes of matter. Changes of matter, physical change, chemical change, classification of matter. Okay, we have the pure substance and mixture. Okay. Hello, mga walaga. And mixture. And then, of course, we deal also with the phases of matter, of course. Okay, in the phases of matter, okay, we chooses the gas first. And then now we mix liquid, gas, and solid in our next topic. And but our changes is also chemical change. Okay, and now we are now going to mixture. Okay, mixture, meaning addition of different elements in the compounds like this. Could it be a heterogeneous mixture or homogeneous mixture, like this, blah blah blah. Okay, get the point? Diba? Okay, now our topic for today, so that's why it's good also to start with understanding of the acids, bases, elements, compounds before going to this. Okay? Ganon. Now this is gonna be one of your favorites, right? This is gonna be chemical equilibrium. Wow. Okay? So ganon. So this is very very important, guys, in understanding the chemical reaction engineering or the chemical kinetics. In determination of the rate of a chemical reaction. Okay, rate R-A-T-R. So many showing R-A-T rate meaning there's time, right? Rate, for example, daily rate. $100 per hour. $200 per hour, meaning rate. The rate there means there's time, okay, in the denominator. Okay, rate. Okay. But if you deal with concentration, so concentration over time, price of the unit over time, and then the price of daily rating, okay, of a worker over time. So $200 per hour per day salary. It's just the same like it's in concentrations, huh? Okay, get the point. Machine metabol. Okay, ganon. Okay, rate. Okay, so this is talking about chemical equilibrium. Oh, ganon. Chemical equilibrium. Okay, equilibrium. Okay? So many to say equal. Because equilibrium, the root word is equal, something like that. Okay. Now, if we have a reaction, not necessarily a reaction, only a single element, for example, or a concentration, right? So for example, ganon, I have kaloka. Okay, I have A going to B, right? So A concentration to B concentration, let's say I have here 1 mole, okay, per liter concentration of A. Okay, ganon. So, by understanding the changes of the chemical reaction, this concentration of A will be decreasing as it goes to B. Okay? So we will say concentration of A decreases. Ganon. Then what will happen to the concentration of B? Concentration of B increases. Okay? Ganon. Because the concentration of A has been transmitted or transmitted or forwarded to B, of course, by common sense, the concentration of B will go high, like that, okay? Now, when we say equilibrium, it talks about the rate, okay? You get the point? When we say chemical equilibrium, we are talking of the rate. So we need to say the rate of the concentration of A, okay, will be equal to the rate of the concentration of B. So that is now in equilibrium because they're equal with each other. Or we can simply say the rate of, okay, forward reaction, forward, capital F, is equal to the rate of the reverse reaction. Or we can say also backward reaction, if you want. Just to say backward and reverse, right? Or English. Okay, something like that. So it's gonna be the rate of the concentration of A will equal to the rate of the concentration of B. The rate of the forward reaction is equal to the rate of the reverse reaction. Okay. Now, in this situation of chemical equilibrium, the concentrations of A is equal to B, right? So this is the time that the concentration of A and B normally will no longer change. Of course, because they are now equal by common sense, okay? But we have to emphasize, okay? Okay, this is the point where the concentration of A and B are no longer changing, okay? Because they are in equilibrium with each other, okay? So this must be emphasized. It's not enough to say the concentration of A is equal to concentration of B. So you have to emphasize really the concentration of A and concentration of B are no longer changing because the rate of the forward reaction is equal to the rate of the reverse reaction. Ganon. You get the point? Now, if we try to interpret this in a graph, like that, graph. So, sa man ang basic graph niya higil na. Okay, so it's gonna be versus the time, versus the time, versus the time. Because you know, this is rate. The time will be there. This topic is really dependent in time. This is not really the same as with the previous problem solvings that we did. That's independent of time. Okay, now dependent with time, something like that. Okay, it's gonna be, for example, we have the graph here, ganon. So the graph in the y-axis, let's say the y-axis is our concentration. The parenthesis is a symbol of a concentration in chemistry, okay? Like that. So we have here A and B concentration, example only, okay? And then we have also the time here, So actually, we have two types of equilibrium, the dynamic and the static equilibrium, something like that, okay? And then I will illustrate to you first the dynamic equilibrium, okay? Then, if the A concentration will decrease, okay, right? As I told you a while ago, the graph will go like this. Okay, and then at the time here, the concentration of A will become steady, like, until it stops. Okay? The same also will be happening. The concentration of B, it will increase, right? As I told you a while ago, it's gonna be like that. And then it will increase the concentration of B, and then slowly it become constant until it will stop later on. Okay, ganon. So, at this point, we will have a dimensional, what do you call this one? Imaginary line, dimensional. Here, at this point here and here, okay, they establish a dynamic equilibrium. Okay? Dynamic equilibrium. Because they are not stopping immediately. Okay, they still have to go a little bit, and then in a linear motion, and then it will stop later on. The same also with the letter B. Okay? Both of them will no longer change after that. Okay? Get the point? This is dynamic equilibrium. Now, we need to have the static equilibrium. In this case, the static equilibrium representation will be based on the rate of the reaction. Because a while ago is the concentration. Okay, so still we have the same graph. Okay, y-axis. Okay, and then the x-axis, time, x-axis, y-axis is your rate of forward reaction and backward reaction. See, R. Ganon. Represented as R. So, R na siya, so it's going to be R and RF. Oh, R. Sorry. Rate of forward reaction and rate of reverse reaction is in the y-axis. Ganon. Now, what will happen now with respect to time in terms of forward reaction? It will decrease, the same as the concentration. Okay? Like that, decrease. O, ganon. And then the other one also, wait, like this is the RF. This is the RF ng mga palangga. Okay? And we have also the rate of the reverse reaction. So it will increase, as I told you a while ago. Like that, ganon. Okay? Now, there's a cross-section where they meet with each other, but they will not isolate, but both of them will meet immediately, and both of them will go straight line, and then it will stop the forward or the backward reaction, reverse reaction, and forward reaction. So this intersection here is the static equilibrium. Okay? But normally, okay, as an engineering student, chemistry student, or let's say chemical engineering student, or DS chemistry student, we will interpret chemical equilibrium as just equilibrium only. We don't specify really what are static and what are dynamic, as long as we learn that is equilibrium. But I have to teach you that there are two types of equilibrium: static equilibrium and dynamic equilibrium. Dynamic equilibrium is really based on the rate of the forward and the backward reaction. And then static equilibrium, something like that, okay? Okay, dynamic equilibrium based on the concentrations of A and B, reactant and the product. And then the concentrations will no longer change by graphing the concentrations versus time. Whereas this static basing on the rate of the forward and backward reaction. Ganon. So, by the time it will reach, they will equal to each other. So this is already static, meaning it will not really change now. But the rate, not the concentration. And then, after these illustrations of the graph, we can finally conclude that the rate of the concentration, regardless of A and B, okay, will go up as the concentration also go up. Okay? Like this. Generally, if the rate of concentration will increase, the concentration also will increase. The rate of forward will increase. Okay, the concentration of the product will increase. Okay, the rate of the reverse will increase. And then your concentration of the reactant also will increase. Something like that, meaning directly proportional with each other. The rate of the reaction, okay, is directly proportional to the concentration. Okay? If you increase the concentration, your rate of reaction also will increase. Something like that. Okay? That's the theory behind upon or after illustrating the graphical representations of the rate of the reaction versus time and the concentration versus the time. Something like that. Now, since we are dealing with the chemical equilibrium, in our general chemistry lectures, we are very, happy to understand like that, okay, that we have a KEQ, ganon. Okay, KEQ, right? KEQ stands for chemical equilibrium, constant. K is constant because it don't have the unit of measure. Meaning, it is the result of the ratio between two quantities in the numerator divided by the denominator. something like so. No unit. That's why it's constant, something like that. So KEQ is chemical equilibrium constant. That is the term. Akong isulat for the purpose of memorization. Chemical equilibrium, okay, constant. Okay, ganon. That's KEQ. KW. Remember, I discussed this already. KW is the chemical, okay, or let us say, no need to put chemical because these are all chemical. Okay, O2 ionization, okay, equilibrium constant, too much, right? Equilibrium constant of water. Okay, the K term is auto-ionization, is the technical term for this KW. Okay, so that's remember. KW, oh my gosh, auto-ionization, because the chemical equilibrium is very easy to detect already. So, KEQ, okay, chemical equilibrium constant. KW, auto-ionization, chemical equilibrium constant of water. Because KW is only water, no other. That's why W. Okay. But for KEQ, can be any body. Okay? Could be acid, base, like that, buffer, whatever. Okay? So KEQ can be also KA, KB, KC, like that. So a lot. Ka is the chemical equilibrium constant of an acid. The subscript will tell you what kind of chemical equilibrium is that. For example, Ka, chemical equilibrium constant of an acid. Kb, chemical equilibrium constant of the base, something like that. If you found Kc, what's this? Okay, Kc is general. That is chemical equilibrium of the concentrations. That's why you see. So it's either be the product and either be the reactant. Okay? Like that. Okay? But be careful, it will confuse to the letters, huh? KC, or chemical equilibrium of the concentration. Okay. Chemical equilibrium of the concentration. And there's also constant. Because still K. Okay? Be careful in your memorization. Okay? Chemical equilibrium of the concentration constant. But actually, we will treat this as constants, all right? But I'm telling you for the purpose of discussion only that you should know the technicalities, how you say it. Okay, if you're a chemistry student, chemical engineering student, okay, this chemistry student, or any related science student, because it's understood that we have a very solid chemistry study compared to other engineering courses. Okay? Because we are really centered and focusing to chemistry and other pure sciences and also physics. Okay, physics. Okay, physics and chemistry are needed for the concepts if we have that kind of science courses. Okay, now equilibrium constant or chemical equilibrium constant of the concentration subdivided into Kp and Kr, meaning chemical equilibrium constant of the product. Ganon. Take note that subscript. Okay, then Kr, you say chemical equilibrium constant of the reactant, because that is Kr. So you should be smart enough to detect the subscript alone, because we know already that K is a chemical equilibrium constant. And then you have to attach in the terminology what you are referring for, like that. So you have now KAQ, KA, KB, KC, KP, KR. What else? We have KP, but small letter p. Here KP is K capital P for the chemical equilibrium constant of the product. Okay, but here K small letter p subscript. This means chemical equilibrium constant of the partial pressure. Partial pressure. This is very important if we try to connect and deal with gases mixed with liquids and solids. Because sometimes it will be rumbled na. Okay, rumbled. You have to add solid plus gas plus liquid and you have to detect what equilibrium. So para di tayo maglibog, that's why I already illustrate to you the difference of the symbols to be used. Okay, this is gonna be like this in discussion before you discuss properly to your students. Like that, because maglibog man ang estudyante, nakakig mga symbol na gigamit. Okay, and then they don't know. That's what anong maestra, ganan. So it should be, emphasized very well to the students. What are those nomenclature you used, something like that, or variables, so that they will never be lost. Okay, for the purpose of better understanding. Okay, it's not like that. Okay, so you will not become effective for that. Okay, something like that. If you will go very, very, jilly, something like that, very fast. Quite. Why some more? Quite. I'm talking with Taiwanese, Chinese, Mandarin Chinese. Why some more? Hindi yung kanta, quite ma. Diba? Like that. So basic, lang siya, Mandarin Chinese, because I worked in Taiwan for 3 years. Okay? Like that. Okay, so small, ni hao ma, diba? Okay, I really miss talking in, Chinese language also. Okay, my gosh. Only very small, I can talk and speak in Mandarin Chinese. Okay, not spontaneous. Hello. Okay. Ni hao ma. Okay, let's go back. Okay, let's go back na talaga siya, guys. Okay, now guys, we will also understand, the equilibrium expression. Equilibrium expression, this is now general, Equilibrium expression, so let's go back again and draw. A going to B, ganon. And then, okay, ganon siya, guys, and then we have now, so the rate of reaction A, or rate of forward reaction, okay, is equal to, this is a standard of how we write. Okay, this is the equilibrium constant K, and then ganon siya, and then concentration of A, ganon. So that is forward. Okay, if you speak about forward, the concentration you multiply with the equilibrium constant is the reactant. Okay, like that. And then rate of reverse reaction, R. So it's gonna be the equilibrium constant K times the concentration of B, ganon. Okay, like that. So, because that is reverse. Okay, forward A, backward reverse B, ganon. Okay, but in the reverse, the equilibrium constant is no longer positive. It's gonna be K subscript -1. Because this is the reverse equilibrium constant of the positive K. Something like that. You get the point? Okay, we put subscript -1 because if you put negative in the K, that is not yet a number. Okay, this is still a variable or a letter. That's why we put -1 on the subscript. Okay? Like that. You get the point? Ganon ang mahitabo. Okay. Now, since every standard equations and formulas are following math, math? Algebra, basic math, okay? Still, we apply the theory and rules of mathematics. Okay, like that. For example, the rule of mathematics, crisscross multiplication, divide both sides by something in order we can have this quantity to be solved, multiply the whole quantity so that we can solve what is really required. And these techniques will always be used every time in a problem solving. Okay, because usually what is being asked, it should be simplified. Lagyan mo kayo ng bulubog sa mga formulas. All you have to do is to eliminate that by dividing both sides to something so that you will have only one quantity to find out. So this is a technique already. Okay, like that. and then also divide by both sides by certain variable or number chupa-chucho, so that it will become simplified. Then crisscross multiplication like that, so for what is being required, and then another will also transpose chupa-chucho from positive, it will become negative. If you're going to the left, these are the rules of algebra that should be remembered a trillion times for all engineering students, because this will be used until second year college, until you go up. You go up in your, it's always like this all the time, really, guys, especially in your major. Okay, like that. So the complicated rules will be there, okay, soon, like that. But the basic you should not forget, the foundation. Again, just like making a bridge. If the foundation is very weak, it will collapse. Just like that principles in having the knowledge. You should start with the basic foundation. Especially engineers, you should build the basic talaga siya on the math, and that is algebra. Okay? Algebra, geometry, trigonometry, ganon. Or the solid mensuration topic. Not too much with the probability and statistics. Not so much for that, okay? Because it's always, possible outcomes. So more on the prediction and forecast what will be the possible outcome. That's prove and stats. But really, algebra talaga magbalik-balik, guys, sa math, okay? Na po yung mga angles, especially if you're dealing with the angle of inclination, how you can make this particular angle like that, especially pipeline, how to build a pipeline at a certain angle. Then you can use also the trigonometry to design the pipeline stages. It's going up, downside, 45 degree, 90 degree, like that. It's also analytical geometry. Okay, like that. So always like that, basic math from the bottom. Okay, you get the point. So we will apply that there also here. Okay, in chemistry. Okay, applying math algebra. Okay, now we have the concentration, something chupa-chucho. Take note the forward. Ganon. Okay. Ganon. Diba? And also, is equal to, because this is an equilibrium, right? Okay, as I told you earlier, that RF is equal to RR in static equilibrium. So this is also equal in Ka and K negative 1B. Take the ratio and the proportion. Ganon. Okay, so Ka is equals to ganon K negative 1B, or ratio and proportion. Denominator, fraction, ganon, chupa-chucho. Ganon. Okay. Now you will divide to something. Okay? Kung sa man mo i-divide mo gayon na para makancel mo ang chupa-chucho. Okay? Kung sa man mo i-divide. Okay? So that makancel ang A sa numerator, you have to put A. Okay? Meaning to say, divide both sides. If you multiply both sides, that's rule of algebra. You have also divide both sides, still rule of algebra. In this case, we divide both sides, not multiply both sides. Okay? Like that. So, K negative 1B. So, we need to divide both sides. So, understood, you have to divide by A so that makancel ang K. Equilibrium constant na lang nabilin. So, our purpose here is equilibrium constant, what will be simplified here. So, we don't need the A. That's why we divide that with capital A, like that. And the other one also, okay, we don't need more, the K minus 1. So let's divide it with K minus 1. Okay? So that makancel ang K minus 1. Okay, now, we will need A because expression of the concentration. Okay? It's impossible mo balik o B. B divided by B is equals to 1. Right? Common sense talaga, guys. Okay? So you have to divide this with A. Okay? So, K, negative 1. So, cancel. So, what will left? Cancel. Ganon. What will be left is K equilibrium constant is equals to K of the forward constant and K of the reverse constant equilibrium. Okay, ganon is equal also to the concentration of B over the concentration of A. So, this is now your standard formula of chemical equilibrium. Okay, like that. It's here, then we will apply the math. Okay, here, math. It's no longer chemistry here, it's math. Okay, because you're aftering now on the chemical equilibrium constant. So therefore, we can conclude that our chemical equilibrium constant is equal to the chemical equilibrium constant to the forward reaction over to the chemical equilibrium constant of the reverse reaction is also equal to the concentration of the product B over the concentration of the product A. In this situation, A to B only. Because there are a lot of chemical reactions also. For example, A plus B is equals to C plus D, or 2B is equals to 2A plus B. But you need to follow the same principle in this. This is only general. You get the point? Okay, so the reaction will be based on the 5 types of chemical reaction. First, decomposition reaction, combination and synthesis reaction. C, combustion reaction that comprises of complete combustion and incomplete combustion. The single replacement or single displacement. The double replacement or the double displacement. And the last will be the photosynthesis. Okay, there are 6 types of chemical reaction. Photosynthesis and combustion are special chemical reactions. Most of the time, you will be dealing with the combination, synthesis, decomposition, single replacement, double replacement, like the chuba-chucho. Okay, decomposition is more on splitting the molecules. That's why you apply heat and temperature through a physical process or whatever chemical changes like that involves a lot of process. So ganun siya. Ma-apply niya ay chemical equilibrium na topic. Okay? Ma-apply ito tanang mga chemical reaction dito. Okay? Pati ang mga balance chemical equation, ma-apply niya po dito. Okay? Mag-connect siya, connecting the dots. Okay? Like that. Now, before going further, since we are studying chemical equilibrium here now in my new topic for this day, okay, under the classification of matter and changes of matter and studying the matter in chemistry, okay, because as told you, chemistry is a branch of science that deals with the study of matter and the changes it undergoes. Meaning to say, if there's no changes, that is not chemistry. Even though you have the composition, the combination, the interaction, okay, or reaction, if there's no changes that it undergoes, then it is not a chemistry. Okay? You get the point. So the K word is changes. Okay? So it could be a physical change or a chemical change. Something like that. Okay. Now going back to the chemical equilibrium. Okay, if you understand chemical equilibrium, okay, we need also to study the, what they call one? Ice technique. Okay, what is Mr. Sotero? What is ice? Okay, ice technique, ice. Ganon. Ganon. So, ice technique. Okay, I means initially, okay, and then C, when it goes, changes from initial to final, and E, at equilibrium. Okay, at equilibrium. Okay, mo siya gamito ng ice technique always, how to compute for the concentrations of chuba-chucho. Okay, first initial concentration, and then final concentration, and then concentration at equilibrium. Okay, the purpose to know both the reactant and the product. It's not enough to determine the final concentration because we should also assess the initial concentration behavior throughout the process. Okay, that's the point. So we have to know the initial, the final, and also at equilibrium, because that is the stage in which the concentration is no longer changing, and it's easy to detect and compute other quantities involved in your chemical reaction. For example, the mole fraction, the partial pressure, the density, the viscosity, other physical properties. Okay, mass, volume, volumetric flow rates, mass flow rates, like that, and any other physical properties that we're trying to compute, as long as you deal with initial, final, and at equilibrium. So this is what we call as an ICE technique in the topic of chemical equilibrium. You get the point? So mag-graph ka. Initial, table, kasi may tagbo, and then final. Di ba guys, naalala siya? Hello, mga palangga. Nawala akong microphone.
Input mode.
Hello mga palangga, buhay pa ba kayo? Okay. Buhay pa ba tayo? So I initial, F final, and then at equilibrium E. So here we have a concentration. Now since you have the expression of equilibrium, then substitute that there, and I can put what is being asked. None. So it's up to you now how you analyze the problems regarding chemical equilibrium. Any questions so far? Before going to chemical equilibrium, I must explain first this. Okay, nakaloka. Okay. This is really the main point. Kung magluto ka, magiging siya ang main Ricardo. It's just the same also. In chemistry, we have also main ingredients to understand further. Okay. First, we have the law of conservation of matter. Law of conservation. You should understand this because it will be used all the time in your higher subjects. Physical chemistry, thermodynamics, unit process, unit operations, transport phenomena, okay, like that. Heat transfer, mass transfer, fluid dynamics, like that. Name it. This will be used all the time, okay? Law of conservation of energy, okay, like that. So, law of conservation of mass, okay? Law of conservation of matter. Law of conservation of kinetic energy. This is in the case in the physics, wherein you have to try to conserve the kinetic energy. Okay, like that. Not only the potential energy is at rest, right? It is a motion at rest, so no need to conserve. It is the kinetic energy that you are going to conserve, and that law is referring to the law of conservation of kinetic energy, so that we can understand properly what is the momentum. Okay, momentum equals to mass times velocity. Could it be an inelastic momentum or elastic momentum? Then we will determine there what are the criteria to be called as an elastic momentum and inelastic momentum. And there's a difference. Okay, something like that. And that's in physics, but we are still in chemistry. We don't touch the law of conservation of kinetic energy, right? So let's erase this one. Okay? We will be touching the law of conservation of energy, the law of conservation of mass, and the law of conservation of matter. Okay? So if that is the case, guys, more siya mga sentence, then you have to identify what is an energy, what is a mass, and what is a matter. By understanding the statements, you have to scrutinize the terms involved like that. It's very easy to understand a law. That is a principle, a concept, a postulation, a scientific research. And conservation is very easy. You need to conserve so that there will be no wastes. Okay, something like there will be no losses in the atmosphere, in the land, in the water, in the air. So that's the term conservation. That's why we have conservation of sources, energy sources, or whatever. Or any, school supplies conservation, recycling, reuse, reduction of the source, or name it, or whatever. Or proper disposal of any resources around us. So that's part of conservation. It's very easy to understand. Now we go to energy. What is an energy? So that before going further, we have the idea, that it's going to be like that. Because it's not easy, you will go directly and the students did not understand the terminology. Okay, so problem. Okay, focusing only by numbers. Okay, it's not really that good enough if you will never introduce the theoretical concepts before going further. Because later on, it's another thing. They will be focusing on numbers now during problems. At least we know the terminology because all questions are expressed in terminologies. It will help us for better interpretation, better understanding for our comprehension, how to solve problems in the future. Okay, because all questions are expressed in English language. Something like that. Now, what is an energy? Anybody? Students, okay. What is an energy? Or remember na ko sa very basic ganon. Energy, mga palangga. Energy is the capacity or the ability to do work. Okay, you remember that one already, right? So again, energy is the capacity or the ability to do work. So there's no energy if you cannot perform a work. Of course. If you are stagnant, there's no energy because you're not moving. Common sense. Now, I'm standing in front of you. I don't have an energy because I'm just standing. I did not cover a certain motion at a particular distance. Something like that. Whether the distance is vertical, side to side, or backward, forward, or rotational, as long as I have the movement, I have the motion, I have the covered distance, and that's the time I have the energy. And you get the point. Now, we go back to the formula of work. So work is equal to force times distance. Okay, this always have a distance covered when you have the energy. Okay, for example, if I do jogging in the cricket oval, if I do the gym, I have to move, right? I covered a distance from one point to another point. Or I held the dumbbell downward, upward, downward, upward. So vertical distance is there. Height, Height, and you apply the force. Then work is equal to force times distance. Since I said that energy is the ability and the capacity to do work, then you have the energy. Something like that. So we will go back to the basics. Now, what is a mass? Okay, mass is a unit of measure, a physical property. Okay, so that meaning to say, mass is measurable and quantifiable. Something like with a specific unit of consideration. For example, if it is an SI unit, metric system, or English unit, and then it is a liquid, it will occupy the shape of a container. Okay? Like that. If it is solid, not necessarily. And then if it is a gas, not necessarily also. Always the liquid will occupy the shape of the container. Especially if you put water. The shape also of a container is also dependent to water. The water is dependent to the shape of the container. Okay? Something like that. You get the point? So that is physical property and that is extrinsic property. Extrinsic or extensive property. Dependent to the sample of the size of the system and to the type of matter present and also to the sample of the quantity being present there. Ano siya? Mass. Then matter. Very easy. You learned this in your elementary level. I think grade 3 or grade 4. Elementary grade school level. Matter is anything that occupies space and has mass or weight. And that is matter. 3 phases of matter: solid, liquid, and gas. And now you understand properly everything now. The terminologies. Now we go now what is really the law of conservation of energy. What is that all about? Actually, in physics and chemistry, it has a meaning. Okay, law of conservation of energy is saying energy can neither be created nor can be destroyed, but it can be transformed to various forms of energies around us. And there's a lot. For example, light energy, mechanical energy, chemical energy, pneumatic energy, hydraulic energy, radiation energy, acoustic energy, nuclear energy, and name it, so many. Okay? You get the point. Now, we have the law of conservation of mass. This is a little bit different because this is dealing with the chemical reactions. Okay, so this is the total number of atoms is always equal to the, forgot. The total number of atoms in a reactant is always equal to the total number of atoms in the product at equilibrium, something like that. Meaning equal, meaning it doesn't depend on the time. So independent of time. Okay, you get the point? That's why we always balance the equation, we always solve the stoichiometric problems. As you can notice, there's no time computation there. Time computation is not involved, right? So that's it. T-I-M-E, hour, minute, days, year, century, decade, name it. Okay? Nag-start yung sa primero, seconds, minutes, hour, day, week, month, okay? Quarter, biannual, okay, annual, century, decade. So these are time. Okay, so these are all the component of array. R, A, T, E. You get the point? And now we go to the law of conservation of matter. And this is really the most important one. Again, matter can neither be created nor can be destroyed by ordinary chemical means. Meaning to say, it should be chemical change. Okay? In which there's an alteration and deformation and changes of the forms and states of matter. Meaning to say, solid converted to liquid, liquid converted to gas, then it will be reversed. And this is a time also that a lot of processes involved, such as, for example, vaporization, evaporation, condensation, boiling, heating, condensation, filtration, sedimentation, leaching, flotation, distillation, fractional distillation, absorption, adsorption, extraction, liquid-liquid extraction, centrifugation. A lot! These are all physical and chemical separation processes. Okay? If we understand the subject of physical and chemical separation processes, and I think in unit operations 3, we need to understand properly the law of conservation of matter. Okay? Because it's in there. The changes of matter. A physical change and a chemical change. For example, I have condensation. Okay? A change from gas to liquid. Something like that, right? So unsama na siya. So that's only a physical change. Like that. That's, you know, that is a changes in matter. That's why I told you, you have a basic foundation. What is a law of conservation of matter? Because it will be used in your higher subjects. Something like that. Okay. Now, we clearly understand now the law of conservation of energy, law of conservation of mass, law of conservation of matter. Now, it's very, very easy for us to solve problems in chemistry. Okay? Like that. You get the point? Any questions so far? Basic foundations na yun siya guys ang technique. Okay? And stock knowledge and acquired knowledge of pure sciences interconnected among physics, chemistry, biology, something like that. Okay? Biology is very important also to connect with chemistry and physics. Oh my gosh. That's why we have biochemistry or biochemical engineering. Okay guys, any questions so far? If you like this video, you can comment, you can share this video, and you can also like my YT channel, then subscribe if you want, and then you can click the notification bell for some news updates of my senior channel. Thank you so much guys for supporting my YT channel. Really, from the bottom of my heart, my reviews are escalating. Oh my gosh, escalating talaga. Thank you so much. Bye-bye. Kakaloka. Diba? Uy! Mga palangga, nalingaw Kiko Vlogs. Diba? Mga kapatid. Diba? Erase. O, ganon. Diba? Kaloka.